Okay, this is a follow-up on the multimeters lecture that we have done a few days ago. We're going to start fresh with the multisim screen, and whatever we were talking about during the lecture, I'm going to simulate on multisim and see how accurate those readings are going to be. All right, so we're going to start with the clean slate of the multisim software, and I'm just going to go step by step on how to assemble the components. So first thing, I'm going to go and select the place and component, and first things first, we're going to go to sources because we do need a ground. Okay, so ground is in sources and it will be in power sources, and you see here there's a ground. Grab this ground. Well, we don't need to click that, we already have selected here. Click OK, and it's going to be stuck to the mouse. I'm not pressing any buttons. Wherever I click, left click, it's going to be placed. And you know what, we're going to place a couple of the grounds. So we're going to go OK again, and just place a couple of grounds. Now what we're going to also get from power sources, we're going to get the DC power supply, and you see that's the simple symbol for the DC power supply, and we're going to place it somewhere here. We're not worrying about the values yet, we're going to adjust that as we go along. And just for kicks, we're going to get AC power supply. Just click it here, click OK, place it somewhere here. We also need a resistor as a load to our circuit, so we're going to go to the group of basic components, and we're going to look for a resistor. Here it is, and by default it's going to be 1 kilo ohm selected. That's fine. Click, and this is stuck to the mouse. Now we're going to rotate that by pressing Control R. See, Control and R, it's rotating. And this is the orientation that I want. It's still stuck to the mouse, and let's place it somewhere here. Now we have all the components, I think, and we're just going to close that placement window, and we're going to do our connection. So just going to arrange things a little bit out of the way here. Now let's assemble a circuit. Just gonna bring that a little bit this way so we don't get this thing polluted. And just by clicking on these terminals with the left click, we're going to make a connection. Click once, release, and somewhere here, click again to make a turn, and click here. Alright, same thing here. Click and place, and let's just complete the circuit. Technically I could have a switch here, but we're not going to bother with that in this case. Now multisim likes to have a ground, so let's just add the ground. If you don't have a ground selected, multisim might have a trouble simulating the actions. Okay, now this ground, we're going to save it for later. Okay, so well, let's adjust some of the values on that. So I'm going to double click on this DC power supply, or you can just right click on it and call up properties, the same thing. Let's adjust the voltage. Well, you know what, let's have 5 volts DC on this thing. Yeah, here we go, 5 volts DC. This is positive, this is the negative side of that. Now this is a little bit too much for us, so let's double click on the AC power supply, and let's make this thing, well, a magic number, 7.07 volts, and you see RMS. Okay, all right, which means root mean square. Click OK. There we go. So we have our values. Now if we start simulating the circuit by pressing that run button, alright, circuit is working, the current is flowing, but can we see anything? No. Alright, let's stop the simulation. We're going to add a voltmeter, and the meters are in this section here. And this very first icon is a multimeter, so I'm going to click once. This thing becomes stuck to the mouse, and we're going to place it somewhere here. All right, cool. Now let's connect the voltmeter. We're going to connect the voltmeter across the resistor, which means basically we're going to get whatever is between these 2 points. All right, and the resistor just completes the circuit. This is our load. All right. Connect it here and connect it here. It's fine. Now, if we double click on this meter, we're going to get the display of it. So double click. Oh, look at this. Here's our display. Let's put this thing somewhere around here. Okay. Now, we have this thing selected as a voltmeter, this multimeter, and on the DC. Alright, when we start simulating the circuit, what is it that we're going to get? This thing is selected to the DC, which means the multimeter is going to ignore the AC part, sort of ignore it. Because the waveform, as a perfect waveform, so it's not really ignoring it. It's taking the average of the AC component of this, and the average component of the average DC component of this AC waveform is going to be whatever is in the middle of the waveform, which means it's sitting right on top of the 5 volts. So that will be almost seen as ignored, but not. It's the average. The average DC component of this is basically 5, well, it's going to be sitting at 5 volts. Let's confirm that, shall we? The multimeter should show 5 volt DC. Press play. Boom. And look at this. It is showing us 5 volts. Good. Now, let's stop the simulation and switch the multimeter into an AC voltmeter. So click on that here. Now, the DC component of this whole circuit is going to be ignored. Doesn't mean it's not there. We're just switched the multimeter to display just the AC component of that. And it's going to show us the RMS value, because multimeter is showing the RMS value. And we have 7.07 volt RMS. So it should show 7.07 volts, right? Let's check it out. Alright, it's just showing the AC component of this whole circuit. Okay. Now, let's see what really is happening here on this, in this, what's really flowing through this load. Now, for that, we're going to get something that's called an oscilloscope. And the oscilloscope we're going to use is right here. Let's get the Tektronix. So click on that. It's becoming stuck to the mouse. Let's place this somewhere here and make things a little bit clearer. So I'm going to move the multimeter display over here, and I'm going to bring the oscilloscope this way. Now, what I could do is, here's the ground, and channel 1, 2, 3, and 4. It's a 4-channel. Here's the test point. Excuse me. So I could do ground here, and channel 1 somewhere here, right? But what I'm going to do is, just to make things a little bit clearer, delete. I'm going to bring that ground right here. Okay, so oops. So this point here is the same as this point. Okay, now let's connect channel 1 to the side of the resistor. And of course, in order to get the display on the scope, I'm going to double click on the scope. And here is our view of our scope. Of course, we have to turn this on. Boom, turned on. Okay, let's start simulation. Oh, we got some waveform happening here. What is it that we have? First, this is channel 1. We can turn it on, turn it off. We can call the menu of the channel 1. So we're on the DC coupling here, which means it is going to show whatever it is. It's going to not ignore the DC component, and it's going to show us the display value, the waveform that is produced by the AC value right now as well. So let's just adjust the vertical deflection sensitivity into something that we could actually see. Alright, notice that when I do that, I turn this knob, this value changes. Now it's 5 volts per division. This is a division. 1 square is a division. So 5 volts per division. Right? What do we have? One thing also we need to know. This is the ground reference right here. Okay. Now, we see this thing is not equally displaced between the ground line on top as well as on the bottom. Looks like the whole waveform is raised a little bit. Well, let's see if we can ignore the DC part of it by selecting the coupling. And that basically comes up if we call up the channel 1 menu. So we're coupling DC, and this is a toggle button. So let's toggle that. Oh, here's AC. See what's the difference? Here's the DC coupling, is showing us this and that together. But if we just select the AC coupling, this whole thing is going to move down because the DC portion, which is 5 volts, is going to be ignored, which means this whole waveform is going to move 1 division down because it is sitting on top of the whole waveform is sitting on top of, it's riding on top of the 5 volts DC. So since each division is 5 volts, this whole thing, if you watch that bottom peak of that, it should move 1 division. Okay, let's try it. Boom. Now here is the ground reference, and the waveform is distributed evenly across the ground level. Okay. Now let's see, because right now, remember we were talking about peak-to-peak value and peak value and RMS value. All right. So here's the ground level. How far does it go up? 5 volts per division. So let's see. 5 volts, 10 volts. It reaches 10 volts. So the peak of that is 10 volts. The bottom peak is what? 2 divisions times 5. Another 10 volts. So we have 20 volts peak to peak. We have 10 volts peak and 10 volts multiplied by 0.707, which is the RMS value. The RMS value of the waveform is the top peak of the uniformly placed waveform times, well, basically it's about 70% of the top peak. It is 7.07. So this 10 volts peak here is multiplied by 0.707 is going to give us 7.07. That's why I chose this value of the RMS of the power supply here. Right? So really this whole waveform, if we choose the DC coupling to show us the whole thing without ignoring any values, so what we have here is we have a 20 volts peak to peak waveform riding on 5 volts DC. So here's the middle of that waveform right here. and the ground is here, so that's 5 volts. So the peak value of that is, of the pure AC waveform, the peak of that is 10 volts, and the RMS value of that is 7.07 volts. See that here? Alright, let's try it again. We are gonna, let's see if I do I have to stop the simulation or not. No, I don't have to stop. I just selected the DC value. So the DC component, the average DC component of this whole signal is 5 volts, and it makes sense because we have a 5 volts DC here. So the whole thing is raised 5 volts from the ground. And the AC RMS value, if we ignore that, is 7.07 volts RMS, which would give us, if we had 20 volts peak to peak, sinusoidal waveform. Okay, I hope it kind of clears it up. Try to recreate this thing, because I know you're going to be using multisim, so hopefully this thing helps you with other subjects as well.